has a lot of publication on the crystallization of honey. So he's going to talk about crystallization of raisin, farm to fundamental. The floor is yours, Prof, and you have 15 minutes. I will just show you once there's 2 minutes and a minute left, and then we'll have 5 minutes for questions.
Thank you very much, and also thanks for inviting me to give a talk on the topic. Actually, the previous topic was different, there, and that was also very interesting. So I thought this aligns better with the theme of the workshop of seminar today. So I'm presenting on the controlling the crystallization of sugar in resins, farms to fundamentals. This work was done collaboratively, in fact, with the institutions in Chile. The issue there was, the sugar is crystallized on the resins. And you can see that very moldy type of surface. Same thing happens to date as well. If you have noticed, some date might have some sort of moldy type of appearance, and also fig. And the similar process is in honey as well with the crystallization. It's the same sugar crystallizes. Actually, it's not mold. Many people think it's mold, but actually it's the sugar crystal, and that's the glucose crystal. Glucose crystallizes in those products. So what was the problem in Chile? That they were exporting, they still export the raisins, which is dried grapes, to Europe, and then it is shipped. During shipping, when it reaches the destination, you can see this sort of very awful appearance of the raisins, and they are all rejected, because it doesn't appear good. So they wanted to find out what is the reason and why it is happening. They had no idea, So Chile, institutions in Chile invited me. Actually, I didn't initiate the project. They initiated the project. Invited Sergio to collaborate with Chile. The reason why they invited us, there is a reason. I'll just show you. You can see that Australia and Chile is here on the left side. Chile is this long, that one, and that's the Australia. They are far away, but there is some commonality. If you look at from other side, they are very close. Actually, Australia and Chile, they are located in the same latitude. So we also produce the grape in Australia, and they produce the grapes in Chile as well. So Chilean wine and Australian wine, also very famous. They have a similar quality as well. Similar variety, because same weather, actually. Similar weather. So in Australia, that's produced over here, in that region, and then the grapes, and then in Chile, in the same latitude, actually. So, very similar, if you look at the Australia, 98% of the dried grapes are produced in Murray Valley, in that place, what is indicated there. It's a very dry and sunny region. And here, 50% of the dried grapes are produced in Valparaiso region, which is close to that same latitude. And most of the raisins produced are exported to Europe and other countries. Even Australia sometimes imports the raisins from Chile. So just to understand what is happening, because I didn't know, this was a very new area to me as well, because I never worked on it. I have to understand what is happening there. So I have to visit the farms in Australia, farms in Chile as well, how they produce, and just to understand the process, and then identify what is the problem there. So one of the things that dried grapes are produced, or the grapes are grown in very low rain area, warm and dry area, and there should be good irrigation facility. There are certain varieties of grapes, they are dried. Thompson, which is called Sultanas, Flame, Sun Muscat. In fact, Muscat is the variety probably from Oman, that's what they say. And current, there are different varieties, specific varieties, which have got relatively high sugar, actually, 20 to 25% bricks, when they are in the grape, Of course, when you dry them, the sugar concentration goes to 70%, so that goes very high. So they are really dry by using sun drying, and the final drying normally done with the mechanical drying, means gas, heated gas, or heated air, I would say. So first sun drying and then heated drying. And then I visited the farm in Australia where they grow the raisins. So you can see the farmers. Grapes are grown like that. Unfortunately, the time I visited, there were no grapes, because that was not the season. So you can see that that hanging thing. They are all trellis. They call it trellis. And also I visited the Valparaiso region in Chile, where they produce, they cultivate grapes, So you can see very beautiful actually. The Chile where I visited, that region was very beautiful. So in Australia, what they do is they have the trellis. So when they grow, and when the grapes are mature, they cut the branch, totally cut it. And then when you cut it, there is no water supply, then they start drying out. They are almost like dead. So they dry out on the sun, naturally, just leave them there, because they are hanging on the trellis. And then later on, when they are dried, they shake them, and then harvest the semi-dried raisins. When they dry, the moisture is about 20, 22, 25% moisture at the time, but they have to finally dry to 13% moisture. They use the hot air drying for final drying before it goes to the processing plant. Actually, it goes after drying, final drying, it goes to the processing plant, because still the product is very rough, you have got the stems and all the impurities from the plants and even dust, soil. So they have to clean that one. I visited the farm and one farmer, and he was saying that sometimes they are drying it and it rains and it spoils the product. So this is the product produced in Australia. So these raisins in the processing plant, at the processing plant. And they have no issue of crystallization they didn't notice any crystallization of raisins in Australia. Australian situation, there is no problem, okay? Because the way they dry and the way the weather is, the time doesn't have that issue of crystallization. So I noticed that one. And then when you go to the Chile, how they dry on the sun, like you see, they just lay on the ground, very dry, live for a number of days, actually 2-3 weeks, and they dry the raisins there. And then finally they process, final drying. And some of the varieties, actually they dry at 70 degrees Celsius. They use the bone, actually they use the wood, timber, to get the fire, and then they dry on that fire. So, and that variety, the yellow variety, what they have got, they have no issue of crystallization. That variety doesn't have. And they didn't know why it is happening there. In that variety, doesn't have any problem, but in other varieties, we have got the problem. So then I have the processing plant in Chile. And now I have to understand, we have to design, we are working together in Chile as well as in Australia. So we have to find out why it is happening. One of the things that I understand that composition of raisins and honey is same. I noticed that one. First time I discovered. It's the same. Glucose, fructose, sucrose. If you look at the composition, it's all almost the same. It's amazing. I didn't know that. So actually, honey and raisins, dried, they similar composition, same thing we're eating. So that was a good discovery to me, actually. I didn't know that before. So now we have to look at the potential factors, composition, glucose to fructose ratio, whatever we apply to honey, we apply to raisins as well. Water activity, moisture, what is the optimum one? Glass transition, temperature, phase transition, and that applies there as well. And storage temperature, at what temperature we are storing, below or above glass transition temperature, which promotes or slows down the crystallization. All these things, you have to think about that. So we started doing some fundamentals, like if there is a crystallization, there is nucleation and crystal growth. We have to understand that aspect. You get very small crystal, smooth product, jelly structure, and then you don't get any observation of the crystals on the surface. If you have got large crystal, then only you observe that one. So what is happening, why it is happening? So these are the things that we have to understand. And then we try to relate with glass transition and crystallization when there is a nucleation and the crystal growth at different temperature. Nucleation is very fast and closer to the glass transition temperature, and crystal growth is away from the glass transition temperature because of the changes in the molecular mobility. So then what we did is we tried to store the sample at different water activity condition and observe the sugaring or the crystallization of the sugar on the surface. You can see we took 3 varieties, golden, Thompson, and flame. You can see between 0.3 to 5 to 3 to that region, you have got crystallization of sugar. You can see that there is a crystallization. You can generate similar sort of situation what you were noticing. So that means that's very critical factor, the water activity of that one. So that's the danger zone where that may happen, that region. And then we found out that why it is happening, the crystallization of the sugar, when the resins are transported from Chile to Europe, because of the temperature fluctuation. When there is a temperature fluctuation, the temperature goes up in the ship and then goes down again by the time it reaches the Europe, like let us say Paris or France. At the beginning, let us say temperature went to 25, 30 degrees Celsius and dropped to 10 degrees Celsius. So what happens is when you look at the that psychrometric chart, you can see that when they are packed, the sample, the head space, humidity, the evaporation, the equilibrates with when the temperature goes up, there is a more moisture going to even though RH decreases, the moisture goes up in the head space. The absolute humidity goes up in the head space. When it drops, the temperature drops, that humidity increases actually, goes from 50% to 90%. When it goes to 90% humidity, it doesn't diffuse immediately inside. There is a diffusion of moisture inside. So it remains on the surface. So when it remains in the surface, means that it promotes the crystal growth. Even though they are very small crystal, because of the low humidity, on the surface the crystal starts growing fast. So that was pretty explained very well, that why it is happening. So then we try to store the sample for even longer time, 2 months storage at different temperature, 25 degrees Celsius. You observe that visible sugar crystals on the surface. And then we just observe microscopically as well, like just the Maltese cross. You can see that the very bright light of the crystals, just using the simple microscope in different varieties. And you can see using a different humidity that was evident. And then this is just about the honey. Similar process happens to honey. Honey, when you hold the honey at 25 degrees Celsius, there is no crystallization. But same honey, when you hold it at 15 degrees Celsius, that crystallizes. So in other case, same honey, if you hold it at 5 degrees, not 25, hold it at 5 degrees Celsius, no crystallization. There is no crystallization if you hold at 5 degrees Celsius. But if you hold it at 15 degrees, it crystallizes. Okay? So there is a nucleation and then crystal growth affected by the temperature. So this is the resin that what you can use for honey. Similar sort of thing we can do with the resins as well. And then we try to put the resins at different temperature, 5 degree, 15 degree, 25 degrees Celsius, and observe the crystallization. In all the cases, whether it is 5 or 15, in all the cases we saw the crystals growing. But in some cases it's not visible, in some cases it's visible. Depends on, even the crystals are there, because they are not growing, or there are large number of crystals at lower temperature, they are not going to bigger crystals. So there is no change happening on the surface in some cases, depending on the temperature condition. So even at 5 degrees Celsius, you don't see any crystal, but when you look at the microscope, you see the crystals. Okay, but it's not coming on the surface. So we did work with, just to prove that there are crystals, the crystalline sucrose. So we use XRD analysis as well. And then we found out the Australian-Thomson resins, not much changes. That was another thing that
1 minute,
crystallization.
1 minute.
Yeah. So that was done, and in parallel, it was done in Chile as well. That university, that similar sort of work. So in parallel. So finally, our analysis was that the XRD results showed that all resins trace contain sugar crystals, although not visible with eyes. All of them, they have sugar crystals. Small sugar crystal, okay, but not visible for eyes. Water activity for visual crystallization, that's a danger zone. I told you, if the water activity goes to 0.55 above, there is a surface crystallization. Okay, so we identified that is due to temperature fluctuation. Low temperature, 5 degrees, doesn't show sugaring or crystallization on the surface only. There are crystals, but doesn't appear on the surface. Pre-nucleation, the solution is that you pre-nucleate at holding at 5 degrees. That nucleation is very good at that temperature, but doesn't grow, So that helps to avoid that one. And then one of the things that that experiment was done in Chile, that melting because all of the grapes, dried grapes, will have some very small crystals. But if you can melt that nuclei by heating to 60-70 degrees Celsius, that is happening in Chile in the process. Certain varieties, they do that, not all the varieties. If you can melt that nuclei by drying at very high temperature initially, that melts the nuclei, and then that avoids the problem as well. So we could see that the mechanism as well as how you resolve the problem. Thank you very much. Thank you. And I would definitely like to thank everyone. Sergio, Professor Sergio, Paulina, she was the research officer, and then my postdoc as well as a master student in Australia. Thank you.
You look younger there.
I'm always young, actually. Still young. I think about later, after 5 years, I'll be younger.
Thank you, Prof. Bhesh, for the nice presentation.